Hi everyone, Miss Pellegrino here. In this video, we're going to be learning about exponents. Exponents are a way of writing repeated multiplication. So let's take a look at some examples. Let's say we have the problem 10 times 10. We can write that with an exponent. So for an exponent, we see that we're multiplying tens, so we're going to write a big 10. I see that we have two tens being multiplied, so we're going to write a little 2 up to the side. This 10 is our base number. It tells us what number is being multiplied. This 2 is our exponent. It tells us how many times that 10 is being multiplied. So I have 10 with an exponent of 2. And I would read that 10 to the second power. Let's look at another example. Let's say we had 10 times 10 times 10. So here, 10 is still the number being multiplied. So my base number is still going to be 10. This time I have 3 tens, so my exponent will be a 3. And I would read that 10 to the third power. You try. How would you write this problem with an exponent? Try it on your whiteboard. Pause the video if you need a moment. All right, hopefully you figured out that your base number is going to be 10 because it's still the number being multiplied. We have 4 tens, so our exponent will be 4. And I would read that 10 to the fourth power. Now, all the problems we've done so far have dealt with tens. You can do exponents with other base numbers. It doesn't have to be tens. But we've been using tens because tens have a special pattern. So let's see if we can find that pattern when we look at other powers of 10. First off, take a look at 10 to the first power. So we learned that this number is our base, so it tells us what's being multiplied. And this number is our exponent. It tells me how many times it's being multiplied. This is a 1, so I only need 1 10. Well, 10 times 1 is 10, so we keep 10 here. So 10 to the first power is 10. We learned that 10 to the second power is the same as writing 10 2 times. So we'll put 10 times 10. Well, 10 times 10, we all know that that is 100. What about 10 to the third power? Well, from our last slide, we know that that means we're multiplying tens, and the exponent tells us that we need 3 tens. So I'd write 10 times 10 times 10. 10 times 10 is 100, and 100 times 10 more is 1,000. Do you see the pattern yet? Let's try one more and see if you can spot it. So take a close look at your exponents and at our final answers. Let's try 10 to the fourth power. We know that that means we're multiplying tens, and that exponent tells us that we need 4 tens. So I'm going to multiply 10 times 10 times 10. Well, I know that 10 times 10 is 100. And 10 times 10 over here is also 100. And 100 times 100, I can use my zeros trick and know that 1 times 1 is 1, and we need 1, 2, 3, 4 zeros. So I'm going to write out 4 zeros on my answer to get 10,000. Do you guys see our pattern? Take a look at our exponents and the number of zeros on our final answer. We started with 10 to the first power. Our final answer was 10. That has 1 0. Then we looked at 10 to the second power. Our exponent was 2, and our final answer had 2 zeros. We did 10 to the third power. Exponent is 3, and our final answer, 1,000, has 3 zeros. Then we did 10 to the fourth power. Exponent is 4, and our answer has 4 zeros. So when we're dealing with powers of 10, the number in our exponent tells us the number of zeros on our final product. So a pretty neat pattern that we're going to see in action in some of our other examples. So now that we've talked about exponents and powers of 10, let's take a look at some of the kinds of problems you'll see in today's work. In today's work, you'll be seeing problems kind of like this. So you've already done problems like these before. You know that 9 times 100, well, 9 times 1 is 9. We have 2 zeros, so we'll put 2 zeros on our answer. 9 times 100 is 900. Today's work, though, you may see problems like this. So instead of writing out the 100, they've written it as exponents. So 5 times 10 to the second power. Well, we know that 10 to the second power is the same as writing 10 two times. So 10 times 10 equals 100. So this problem is actually saying 5 times 100. 5 times 100 is 500. You try. Oh no, the problem got covered up. Let's see. Okay, I'm going to write a problem over here for you guys. So you try this problem on your whiteboards. Can you figure it out? Well, we know that 10 to the third power, we learned last time that 3 tells us it's going to have 3 zeros. So we know that 10 to the third power is the same as 1,000. 2 times 1,000 is 2,000. These are the kinds of problems you'll see in your math work today. So in summary, exponents are a way of writing repeated multiplication. In an exponent, the base tells you what number is being multiplied, and the exponent tells you how many times you're multiplying that number. With powers of 10, so that's when our base number is 10, the number of zeros in your product is the same as your exponent. Your turn. Try a couple of these on your own. Use your whiteboard. Pause the video so that you have a minute to try these out, and then we'll go over the answers real quick before you start working in your book on your own. Go ahead and pause the video, give it a shot. Okay, so in our first problem, we have 7 times 10 to the first power. So we learned that 10 to the first power is the same as writing 10 one time. So this is like saying 7 times 10, which we know is 70. Our next one is 7 times 10 to the second power. Well, we know that 10 to the second power is the same as writing 10 times 10, which is 100. So this problem is actually asking us 7 times 100, which is 700. In our third one, we have 7 times 10 to the third power. Now we can go ahead and take a shortcut now. Let's use our trick that we learned last time. 10 to the third power is the same as writing 1,000, because that 3 tells us that we need 3 zeros. So this is like saying 7 times 1,000, which is 7,000. And of course, 7 times 10 to the fourth power, we can do the same thing. We know that that's the same as 7 times 10 to the fourth power means I need 4 zeros. So 7 times 10,000, which would give us 70,000. These are the sorts of problems you will see in your book today. Look back in this video if you need help. I will see you guys shortly. Good luck and see you around. Bye, everyone.